What's up, guys? Welcome back. Sorry for not posting yesterday. I really don't have any excuse. I can't, I can't lie. I just didn't feel like recording. Okay, so let's jump straight into it. This is more combinatorics examples. Let's start. How many different committees of 6 students can be formed from a class of 30? So what you should notice straight away is the fact that with a committee, it doesn't matter which order the students are chosen, and none of that matters at all. And if you recall, what I said in the previous video was that when order does not matter, we use the combination formula, right? So you can pause this, do it real quick. Okay, hopefully you paused it and did it. So 6 students chosen from a class of 30, that would be 30 choose 6, which is equal to 30 factorial all over 6 factorial multiplied by 30 minus 6 factorial. Keep in mind, I'm not going to simplify this thing. I don't have a calculator at hand, and the number would probably be enormous. So 24 factorial. So that's the answer for that one. If you don't understand why the order doesn't matter, just think of it like, if you have, let's just say you choose student number 1, student number 2, student number 3. I don't know why I changed to red. But anyway, student number 4 and 5 and 6. Now, if you had chosen them in this order, then and in this order, S4, S3, S6, S5, the orders literally don't matter here. The orders don't matter because it's the same committee. There's no order of importance. It's not like you chose the first one, that's the most important, the second one is the most important. They're all part of the committee, and so because of that, the order does not matter, which is why we used the combination formula. So I hope you understand that, and let's go into the next one. By the way, there's a lot of examples. This video, depending on how long I take to solve and explain each example, this video could be quite long, but I'm not sure. We'll see. How many arrangements of the letters in the word studying contain the letters S, T, Y in that exact order? So we want to know. Let's actually start off by counting how many letters there are on the word studying. There's 1, 2, 3, 4, 5, 6, 7, 8. I don't know why I counted so slowly. There's 7 letters in the word studying, and then there's 3 of these letters, and that's exact order. So I'll give you a second to pause this and try it yourself. Okay, so the way you go about doing this one is that you'll treat the letters S, T, and Y as a single word. As a single letter. So as opposed to treating them as separate letters, you're going to treat it as one. So what you're left with is, let's put a block around it. S, T, Y. Let's just write out the remaining letters. U, D, I, N, G. Studying. Okay, that's what you're left with. And now, what you need to do is count the number of letters. 1, 2, 3, 4, 5, 6. It's a common mistake. I think it could be a common mistake to forget to count this one as 1 and just subtract 3 from 8. So if you say 8 minus 3, that's 5, but the actual number of letters is 6. So maybe just to be safe, if you know you're prone to such mistakes, count them manually, or you could just say 8 minus 3 plus 1. That's a general rule of thumb. So there's 6 letters. So the 6, let's say, letters or 6 characters. And then, I can't spell. Okay, I'm just gonna give up on spelling that altogether. So now 6, and now what we're going to do is by the way, I should have mentioned that the letters should not be repeated. Let's say no repetitions. Because there's no repetitions and there's an equal number of words to the number of spaces there are. By the way, these 3 letters, or the fact that these things counted, that we have treated them as one letter does not mean now that there's any less spaces or any less steps in the process. I mean any less than 6. That's what I mean. And you see what I mean now. So for the first one, there's 1, 2, 3, 4, 5, 6. 6 steps. Remember, in a k-step process, if they're in that based on the multiplication rules, if there's n1 ways, n2 all the way up to nk, then the total number of ways is the product of all of those. So firstly, we have 6. Now one character has been used up, for example. Then we have 5. Another character has been used. 4. Another one, 3. Another one, 2. Another one, 1. So what this is just 6 factorial. This is 6. The answer is 6 factorial. Yeah. On to the next question. And how many arrangements, this is a continuation of the previous question, and how many arrangements have the letter, how do I say contain, have? Let's just say, and how many arrangements contain the letters I, N, and G next to each other in any order? So we have, let's do the same thing where we block off letters I and G, and then we have study. Those ones are left over, but now they can be in any order. So we do the same thing where we have 1, 2, 3, 4, 5, 6 positions, right? Because there's 1, 2, 3, 4, 5, 6 letters, quote unquote. But then, because they can be in any order, we also have to take into account the different positions of these. And since there's 3 in there, like let's just say 1, 2, 3, this here would be 3 this would be 3 factorial. So you'd have to say 6, 5, 4, 3, 2, 1, right? That's the same as in the previous example. But then this, or all of that, would have to be multiplied. Let's say 6 factorial would have to be multiplied by 3 factorial, because there are 3 factorial different ways of arranging the I, N, and G inside that block of letters. You see, so that's how you go about solving those types of problems. On to the next one. What is the total number of different arrangements that can be formed from the word arrangements? So before we start, I want to just say you add one thing which I should have added to this question besides the question mark. Different letters. You should notice that you'll see that there are repetitions of letters. There are multiple A's, multiple R's, multiple E's in this word, and arrangements in which the letters are, they can be swapped, are treated as the same arrangement. So what I mean is, like in the word arrangement, there's nothing differentiating the first and second R. So if we swapped the R's, it would look exactly the same, and so the arrangement would be treated, I don't know why I chose the word arrangement, because now I'm going to say it the whole time. The arrangements of the letters in the word arrangements will be exactly the same, because here we have the R swapped, but it doesn't look different. So yeah, that's what I'm saying. So in order to, get rid of these duplicates, firstly, we do the usual thing where we count the number of letters. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 letters. And so since there's 12 letters, it's the usual thing with 12 factorial different 12 factorial arrangements. And then to get rid of the duplicate arrangements, we would have to divide it by the duplicate number. So the way you do this is, an easy way to do this is, first you write down each letter and how many times it occurs in the word. So A occurs twice, R occurs twice, N occurs twice as well, G occurs once, E occurs twice, M occurs once, E occurs twice, T occurs once, and S occurs once as well. Sorry, I noticed that I put E twice, so I just got rid of that quickly. So in order to get rid of the different things, you'll notice that for the A's, the arrangements of the A's, there'll be 2 factorial different arrangements, and then here there's 2 factorial different arrangements, and here there's 2 factorial different arrangements. What I just mean is, like, in any word, like in the word arrangements, or in any arrangement of the word arrangements, there are 2 ways in which the A's can be swapped around, right? And if there had been like a third A, then there would be 3, and so there would exist 3 factorial different different arrangements of the A. So so what we're going to do is we're going to divide it by the product of all of these. I'm just putting the G, this one here, just to show you the point. You don't actually have to divide by 1, because dividing by 1 of course gives you the exact same answer. Yeah, so what we're going to do is we're gonna get the product of all of these and then divide 12 by that. So it's 2 factorial times 2 factorial times 2 factorial times 1 factorial times 2 factorial times 1 factorial times 1 factorial times 1 factorial. Let me just change the way I wrote my ones here just to make it a little bit more legible. Okay, and that's how you do that. You could simplify. I'm not going to simplify, like I told you. I don't have a calculator at hand. I'm just doing this thing in my mind. So yeah, that's that question. And now onto part B of the question: the total number of arrangements containing the word area. Let's say in that exact order. So we're going to look at what we did in the previous question, and then we're going to look at what we did in 2 questions ago, where we had something similar about the exact order, and that's how we're going to try to combine our knowledge from those two to figure out the answer. But first, I'll give you a second to try to figure it out yourself. Okay, I hope you've tried it out yourself. Let's begin. So we're going to first note that there are 12 letters in the word arrangement, 12 letters in arrangement, and there are 4 letters in the word area, and 4 letters in area. And we're going to do what we did in the first example. Firstly, we're going to find the number. We're going to ignore the fact that there are repetitions. Oh, did I say arrangement or arrangements in the previous one? Arrangements. Let's just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, there's 12 in arrangements. And we're going to first do what we did by blocking off, not blocking off, but blocking, quote unquote, but just putting them together, treating it as a single letter, area, and then we're going to write the remaining letters: R, N, G, E, M, E, no, sorry, M, N, T, S. Let's just count that this number of letters correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, there's 12. So, and now, treating this as one letter, we're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 letters in this case. So, based off the usual rule, we're going to use, based off the multiplication rule, and we're going to know that it's 9 factorial, but we should also have mentioned no repetitions. If there were repetitions, I don't know, that would be a whole different story. Like, if there were repetitions, then this would still count as one letter, but then each one of these would be the number of unique letters that there are in the word. So, but yeah, that's something else. And then what we're going to do now is we're going to bring this list. Now we're going to deal with the repetitions, and then we're just going to bring this list here. No need to write it over when we have technology. I think I'm just going to erase this because this is taking up space. This is also taking up space. We already that pretty much goes without saying. That stuff that I just removed now. And so we're going to deal with the repetitions in the same way that we did in the previous question. You know what? I'm actually so embarrassed. I got this question wrong in an exam. And I'm seeing how easy it was now. But like in the exam, I was so stressed that I blanked out pretty much. Okay, so there we go, folks. There's the answer. This is the answer. This is the number of arrangements. Like I said, you could, I guess, ignore the ones. Let's just remove the ones, to simplify, I guess. And then simplify the twos. That's what's that? 16, 9. Yeah, that's the number. So on to the next question. Of a team of 12 people, in how many ways can a captain and a vice captain be chosen? So I'm going to give you a second to do this yourself. Pause the video, come back, and look at the solution. Okay, so if you did do it, I hope the first step is generally to determine whether to use the permutation formula or to use the combination formula. But you should see that in this case we're choosing one captain. There's no order to speak of, so we're going to use the combination formula. So we're going to use the combination formula in addition to the multiplication rule. So there's 12 people to choose one captain, and then multiply that by, now since there's 12, the captain has already been chosen. We choose the captain first, and then 11, and then you choose one vice captain. That would be 12 factorial. Actually, 12 choose 1 is just 12, but we could for the sake of demonstration we could do it 1 factorial times 12 minus 1 factorial multiplied by 11 factorial over 1 factorial 11 minus 1 factorial. And what you should notice is that this is 12 factorial times 11 factorial over, now we're just going to ignore that, 10 factorial. These two cancel out, and then we're left with 12 factorial over 10 factorial. Yeah, and then you could simplify, but I'm not going to. For interest's sake, I just want to quickly try something and I'll be back. Okay, I realized something. You could have also done this one using permutations. You could say we have what I was testing is whether you could do permutation, because I had a suspicion that a permutation also felt okay in this context, Sorry, I'm just trying to make a bit of space. In fact, what I'm going to do is I'm just going to make this whole thing small. Whee! There we go. So we have two positions that we need to put people in. And in this case, the reason you can use permutations here is because like order kind of matters, because if someone is in the vice captain position, if let's say person A is in the captain position and person B is in the vice captain position, that is different to if person B was in the captain position and person A was in vice captain position. You see? So that's why you could also possibly use a permutation. And let's see how you would use a permutation. You say 12 permutation 2. So let's just write out the whole 12 over 12 minus 2. All factorial, as you see, it gets you to the exact same answer. 12 over 2 factorial. Let's just make this one a bit bigger just to remind you. That is the answer we got. So in this case, you could use either a permutation or a combination. Yeah. Okay. On to the next one. Of a group of 12 men and 11 women, a committee of 7 people needs to be formed. How many committees can be formed? So again, it's the example of a committee. With a committee, the order does not matter. It's not a thing of there's different positions in the committee, and so person one, if let's say person A is at 1, B is at 2, C is at, let's say it's a 5-person committee just for space, and there, let's say this is the same as this because there's no order of importance here that matters. And so in those cases, like we know, as we know, sorry, I don't know why I said like we know, as we know, we would use the combination formula. Oh my gosh, I feel like you guys couldn't see that. Sorry. So 7 people need to be chosen from a group of, firstly, let's calculate the total number of people. 12 men, 11 women, that's 23 people. 23, choose 7. That's just going to be 23 factorial over 7 factorial. 23 minus 7 factorial. So you go to 23 factorial over 7 factorial 16 factorial. By the way, if I ever make like arithmetic mistakes in these videos, don't hesitate to correct me in the comment section. If there's more than one correction, I won't be able to pin them, but like if there's a correction, then I'll pin it just so that people can see that there has been a mistake made. But I'm sure you guys are smart enough to have noticed like any arithmetic mistakes that I make, because after all, I'm only human. I hope I don't. No, that was cringe. Okay, how many committees can be formed with only men? So if what we must notice, only men, there are 12 men, and so it's still a committee of 7. So it's going to be 12, choose 7, 12 factorial over 7 factorial, 12 factorial minus 7, all factorial, that's equal to 12 factorial over 7 factorial times 5 factorial. And yep, that's our answer. I'm saying it like I just looked to like a second screen to confirm. I'm just saying it just because I think it's correct. Sorry guys, I just want to move this up, so I can, because hey, I don't know why. For someone who has like it's not infinite canvas, I guess it's infinite scroll down, but hey, space, what do they call it? Space economy is not good here. How many committees can be formed with at most 1 man? What I want you to notice about at most is that it could include 0 men and it could include 1 man, right? So let's say case 1, 0 men. And so the case in which there are 0 men, then it would be all the women. So 11 women. 11 women choose 7. And then I'm not going to simplify that. And then case 2 is 1 man. So then that would be 11 women. Therefore 11 women, 1 man, and what's 11 minus 1? 10 women. So that would be 1 choose 1. Oh, sorry. 10 choose. How many men were there? 12. 12 choose 1 multiplied. Remember, in this case, we're going to use the multiplication rule because it's multiply. It's n ways of doing the first one. N1 ways of doing the first one, and then however many ways of doing the last 6. So and then 11 choose 6, and then I know I didn't do a video on this, but there's also the additional. In cases where things are completely separate, you see, there's no situation in which there's a committee with 0 men and a committee with 1 man. And so what we're going to do here is we're going to add these up. I should do a video on the addition rule, and hopefully I'll remember. Maybe one of you will remind me to pin it in the comments, or you could just go check on my channel and see if it's up yet if you're watching this in the distant future. If you look at the uploaded time of this thing, it says 30 minutes ago, My G, that video ain't out yet. I ain't even thought about making it. Anyway, yeah, so this is the total answer. It's the number from case 1 plus the number from case 2. And now on to the fourth question, question D. The fourth sub question, how many committees can be formed with at least one man? At least one man. So at least one man, that means one man, 2 men, 3 men, 4 men, 5 men, all the way up to 12 men. But that's a lot. That's a lot to calculate. So what we could do is see how many women would there be in each case. So we could say, oh yeah, we can also look at how many women there be in each case. So in this case, there would be, if there's one man, then there's 10 women, 9 women. Sorry. In the committee, it's going to be 6 women. Why would they be all the way up to 12? 6, 7. So 6 women, 5 women, 4 women, 3 women, 2 women, 1 woman, 0 women. So what I want you to notice is, actually this might not be very easy to notice, but there's something that you can do in this situation where it's inconvenient to calculate the total number. So you could look at the total number of committees that can be formed. Going back to this here question, what's it? 23 choose 7. Right, let's just write that there because I don't want to scroll all the way back up. 23 choose 7. You can look at the total number of committees that can be formed, and then you can say that you can say the total number of committees minus the number of committees with 0 men. You see that neither of these two ways are practical, and so you're going to say minus no committees. No, by the way, this no is not no committees, but number. Let me just write number, just to avoid confusion. Number of committees with 0 men. Right? Because if you think about it, it makes sense that of the total number of committees, if you remove the committees with no men, then you are left with only the committees that have 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, or 7 men, right? So that hopefully that makes sense to you. If it doesn't make sense, you can put a question in the comment section, and hopefully I'll be able to respond and put it in a more intuitive way, I guess, easy to understand way, because that's almost the motto of this channel. I just want to make things easy to understand. Don't want to be overly complicated with things. Anyway, I'm yapping a lot. The number of so we first, to calculate the number of committees with 0 men, we actually calculated this here, the case where there's 11 women. So it's going to be 23 choose 7 minus 11 choose 7. Note that this is not the same as, like, this is not equal to this, guys. That's 11 over 7 is not equal to 11 choose 7. Hey, 7, 11. Anyway, I'm not going to work that out for the sake of time. You can do that with a calculator using the formula. How many committees can be formed with 3 men and 4 women? That's going to be the deal where it's 12 choose 3 multiplied by, remember, multiply, we use the multiplication rule because it's all part of the same case. How many ways can these 3 be chosen? Multiplied. We just break it down into 2 steps. We say this is one step, and then choosing these ones is another step. Right? By the way, these ones, men, step 1, women, step 2. I don't know if you can see that. Step 2. 12, and then here it's going to be 11 choose 4, and then you can work that out yourself using the formula, or rather the formula. There's one formula. And again, let me just move everything up for the sake of space economy. Hey, okay, this video is getting long, but like I said, it's gonna be long. You can watch it on 2 times speed if it's getting boring. I know it's kind of late in the video to say that, but yeah. How many 5-digit numbers where the first digit may not be 0? That makes sense, because if it's 0, 1, 2, 4, 8, this is not a 5-digit, this is a 4-digit number, guys. Come on now. it's the first digit may not be 0 such that each number is even. So what you should see first is that you're choosing from a set. You're choosing from, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what you're doing is you're choosing at each position. But then for the first position, you have 10 options minus 1. The reason you say minus 1 is because you cannot choose 0 as specified in the question. The first digit may not be 0. So here you have 9 options. Oh, by the way, repetitions are allowed in this case. I should have stated that repetitions are allowed. Sorry guys, a lot of these questions I just kind of sucked out of my thumb. Based off of memory. They weren't totally thumbs up. So yeah, 10, sorry, not 10 factorial, but just 10 for the second option, right? Because there's no restrictions on the second digit, no restrictions on the third digit, no restrictions on the fourth digit. But on this one, it has to be even. And how many even numbers are there from 0 to 9? There's 5. There's 0, 2, 4, 6, and 8. That's 5. Ne? Right? Ne means right in Afrikaans or in South African slang. For those who are, international or whatever. So then the total number of ways is 9 times 10 times 10 times 10 times 5. And just to flex a little bit, just to, now that's basic algebra, I can't even lie, it's just 9 times 5 and then add 3 zeros. 45,000. Now we have to choose, now we have to find the number for which each number is a multiple of 5. 5, 6, 7, 8, 9. I'm just doing this for the sake of illustration. You don't have to do this in a question unless you have a pedantic teacher. We always make fun of the pedantic teachers on this channel. No, but pedantic teachers, they're the ones who make you be better, kind of. Anyway, so just like in the previous example, we have 9 for the first one, and then there's no restriction on the second digit, third digit, and fourth digit, right? Because being a multiple of 5, the only thing with a multiple of 5 is that the last number either has to be a 5 or it has to be a 0. So that means you have 2 options for the last one. Therefore, by the multiplication rule, you have 9 times 10 times 10 times 10 times 2. That's equal to 18,000. Yeah, that's the answer to that question. On to the next one. How many 3-digit numbers, now, okay, if you notice now, the set is smaller. How many 3-digit numbers can be formed from the numbers 2, 3, 5, 7, and 8, such that each number is less than, okay, I should say strictly less than, so less than 730. So that does not include 730. Where no, I don't know why I said letters here, man. Numbers. Come on, man. No numbers are repeated. So no numbers are repeated, so we first want to go for the easy ones. The easy ones are the numbers that are, 200, the numbers that are in the 200s, 300s, and 500s. Because those ones are obviously, how do I say this? They're obviously less than 730. So first we're going to go for case 1. First digit is 2. Actually, let's just combine them all in one. 2, 3, or 5. So in the case where the first digit is 2, 3, or 5, then let's just draw it out so that you guys can see. So we said 3-digit numbers. 1, 2, 3. So here we have 3 options for the first number. And then for the second number, there's 1, 2, 3, 4, 5. There are 5 numbers, so then there's 4 numbers left over, and then 3 numbers left over after that. I hope you guys understand that. So, isn't it, we said for case 1, the first digit has to be one of these 3 numbers, and then there's no restriction on the second or third digit. So we look at this set of numbers that they've given us and that they've allowed us to use, and then we notice that one of the digits has already been used, right? Let's say the 2 was used. So now the 2's been used, now we're left with 4. 4 digits left over. So that's why we have 4 here. Then let's say the 5 is used, now we're left with 3. So that's why it's 3 times 4 times 5. 3 times 4 times 3. And that is 36. So let's just put this 36. That's not a minus sign, that's just, putting things there. So now we're going to look at the case where case 2, first digit is 7. But remember the restriction, it has to be strictly less than 730. And so the first digit is going to be 7, so that gives us only one option. And then the second digit has to be 2, because if the second digit was 3, 5, 7, or 8, then it would be greater than 730. So the second digit has to be 2, and then two of the digits have been used already, so that gives us one option. By the way, this I'm not doing this in the usual way where I use this to represent the number of options. I'm just saying the number has this is the number of options. This is the actual number that could go in the position. In this case, the number that could go in the position could be 3, 5, or 8. So we have 3 options there. So it's 1 times 1 times 3. So here it's going to be 3. And then, so the total number would be equal to 36 plus 3, which is equal to 39. This is based on case 1. We add the number of numbers from case 1, add the number of numbers from case 3, and then we get 39. And I believe this is the last one. Yeah, that's all, folks. There's another question down there, but I need to first figure it out before I can, try to explain it to you guys. Here's the last question. In how many ways can 8 people be seated around a circular table? Note that 2 arrangements are considered the same arrangement if they can be rotated from the one arrangement to get to the other. Let me explain what that thing means. So let's say we have person 1, person 1, person 2, person 3, person 4, person 5, person 6, person 7, and person 8. So what I meant by that is, if you can rotate this thing to get, let's say we have another arrangement here that's person 3, person 4, person 5, person 6, person 7, person 8, person 9, and person 8, person 1, and person 2. If you can, these 2 configurations are considered the same, because all that's happened is that you've rotated to go from this one to this one. You've simply rotated everything like counterclockwise. You see that? Yeah, we simply just rotated everything counterclockwise. So that's why we've considered them the same. So the way you go about solving these ones is you say 8. You do the usual thing where there's 8 positions, 1, 2, 3, 4, 5, 6, 7, 8, right? It's 8, and then you can choose 7 from the next one since one person's been used. Then it's 7, then it's 6, then it's 5, then it's 4, then it's 3, then 2, then 1. Okay? But now, in order to get rid of the things that are the same because of rotation, if you notice, it can be rotated the same number of times as there are people. So what I mean by that is, let's say the one could be here, there, 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 and there. So what you can see is that this thing can be rotated in 8 different ways, 8 different ways, and then all of those 8 arrangements would be considered the same. So it's going to be 8 factorial divided by 8, but we know that 8 factorial is just 8 times 7 factorial, right? You can go to one of my previous videos where I give an explanation for that. Therefore, the final answer is 7 factorial. I hope that kind of makes sense. This one, I'm not sure if this one fully makes sense. If I was an animator, I would animate it. But okay, let me just try to give you the different. Let's just use 4 for example, because 4 is a smaller number than 8, and I don't feel like drawing 8 different things. That's all, folks. Okay, it's not all, folks, yet, but so 4, 1, 2, 3, 3 4 1 2 and 2 3 4 1. So if you notice this, if you what you should see, the pattern here is that there are four arrangements which are considered the same. The reason it's 4 is because that's the number of people seated at the table. And so in this case, there would be 8, right? If you notice, the thing I told you about the order being the same, you see how it's just 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. These arrangements are all considered the same. So in order to get rid of them, in order to get rid of all the arrangements, it's going to be just divided by 4. You're just going to divide the thing by 4, and then that will be the answer. So yeah, I hope that explanation makes sense. If it didn't, maybe try watching the video again slowly. If not, you can just put a question in the comment section and I'll get back to it. Maybe even make a video responding to it. Thank you guys for watching. Please consider liking, subscribing, and sharing with your friends. God bless. Goodbye.